Edge computing is rapidly transforming how we process, analyze, and store data. This innovative approach is reshaping traditional IT infrastructures. By strategically moving computation and data storage closer to the very source where data is generated, offering unparalleled efficiency. Instead of relying solely on distant centralized data centers which can introduce delays and bottlenecks, edge computing enables real-time analysis right at the source, reducing latency and improving responsiveness. Consider its impact on factory floors, where immediate decisions can optimize production, in vehicles, enabling safer and more efficient transportation systems, or retail stores, enhancing customer experiences through personalized interactions. This approach significantly reduces latency, ensuring near-instantaneous responses, making it absolutely essential for critical applications like autonomous vehicles, where split-second decisions are paramount, and industrial automation, where precision and speed are key to operational success. In these scenarios, milliseconds truly matter, and edge computing delivers the required performance. Rather than replacing the cloud entirely, which remains a vital resource, edge computing complements it seamlessly, creating a synergistic relationship. This integration results in a more responsive, scalable, and efficient IT ecosystem overall. By filtering and analyzing data locally, closer to where it's generated, organizations can significantly cut bandwidth costs associated with transmitting vast amounts of raw data. Furthermore, they gain faster, more actionable insights, empowering quicker decision-making. Ultimately, this transforms massive data streams into actionable intelligence, driving innovation and efficiency. As AI, 5G, and IoT technologies continue to proliferate and become more deeply integrated into our lives, edge computing is rapidly becoming a mainstream necessity, not just a technological advantage. It's now a critical component for any organization seeking enhanced speed, robust security, and unparalleled operational excellence in today's digital landscape. Recent surveys show a fascinating snapshot of the current state of edge computing. These surveys provide valuable insights into how businesses are perceiving and implementing this transformative technology. That while edge computing is gaining significant attention and generating considerable buzz in the tech world, many organizations are still in the early stages of adoption, carefully evaluating its potential impact and strategizing its integration into their existing infrastructure. They are taking a measured approach, understanding that a successful implementation requires careful planning and execution. Over half of IT professionals, the very people tasked with implementing and managing these systems, admit to only a basic understanding of edge principles, highlighting a critical need for more comprehensive training and education in this rapidly evolving field. This knowledge gap is undoubtedly slowing widespread implementation and hindering organizations from fully capitalizing on the benefits of edge computing. Most companies invest cautiously, carefully weighing the costs and benefits before committing significant resources. The survey data reveals that only a third are dedicating significant IT budgets to edge projects, signaling a reserved approach to financial commitment, while others treat it as experimental, running pilot programs and proof-of-concept projects to assess its viability and potential return on investment. The main drivers for adoption are clear improved performance, enabling faster data processing and reduced latency, and enhanced security, providing a more robust defense against cyber threats by processing data closer to the source. Microsoft Azure IoT Edge leads as the most popular platform, indicating its strong market presence and comprehensive feature set, but organizations are exploring a variety of solutions to fit their needs, demonstrating a willingness to experiment and find the best fit for their specific use cases. This diversity reflects a market in transition, a dynamic landscape where innovation and adaptation are key, with businesses carefully selecting tools that align with their unique goals, ensuring that their technology investments directly support their strategic objectives. As understanding deepens and the benefits become more apparent, investment and adoption are expected to accelerate, paving the way for widespread integration of edge computing across various industries. The biggest advantage of edge computing is speed. Processing data locally slashes latency for critical, real-time applications. This is vital for industries like manufacturing, finance, and retail, where instant decisions drive efficiency and customer experience. Edge computing also boosts security by keeping sensitive data on site, reducing exposure to cyber threats. Hospitals, for example, can analyze patient data internally, sending only summaries to the cloud. Cost savings follow as organizations transmit only essential data. cutting bandwidth and cloud storage expenses. Edge devices also ensure business continuity, operating autonomously even when disconnected from central networks. This resilience is crucial for remote or mission-critical environments. Ultimately, edge computing delivers faster and safer and more reliable operations. The hybrid cloud edge model is the most common approach, blending centralized cloud power with the speed of local edge nodes. Edge handles real-time analytics and decisions, while the cloud manages large-scale data and complex tasks. This flexible architecture lets organizations optimize performance and cost, adapting to diverse business needs. Microsoft Azure IoT Edge stands out for its seamless integration, but AWS, Google, and open-source options like K3s and Edge X Foundry offer strong alternatives. The variety of platforms empowers organizations to choose solutions that fit their technical and strategic requirements. This adaptability is key to building effective, future-proof edge deployments. Today, edge computing is rapidly gaining traction and is most widely used across various industries. Its ability to bring computation and data storage closer to the source of data is proving invaluable. A primary application is for analytics and data caching, where real-time insights are crucial for decision-making. This enables delivering instant insights right at the data's origin, reducing latency and improving responsiveness. Take retail, for example. Edge devices are deployed to analyze video feeds from security cameras and other sources, providing real-time customer data. This empowers retailers to make immediate operational changes, such as optimizing product placement or adjusting staffing levels based on customer traffic. Furthermore, data caching at the edge significantly speeds up content delivery, ensuring a smoother and more responsive experience for end users. This is particularly beneficial for media and software companies, improving user experiences and simultaneously reducing operational costs associated with bandwidth and infrastructure. Beyond these established applications, more advanced uses are rapidly emerging, pushing the boundaries of what's possible with edge computing. Consider the manufacturing sector, where AI models are run directly on edge devices to enable instant quality control, identifying defects in real time and minimizing production errors. Similarly, in agriculture, edge computing facilitates real-time crop analysis, using data from sensors and drones to optimize irrigation, fertilization, and pest control. Smart city projects are also leveraging the power of edge nodes for applications like traffic management, optimizing traffic flow and reducing congestion, and enhancing public safety through real-time surveillance. However, it's important to note that many of these smart city initiatives are still in their early stages of development and deployment. As the technology matures and becomes more accessible, these advanced applications will undoubtedly become mainstream, transforming industries and urban environments alike. This widespread adoption will lead to a fundamental reshaping of industries and a significant enhancement of urban life for citizens around the globe. The true power of edge computing lies in its versatility, unlocking new possibilities and driving innovation across a diverse range of sectors. Looking ahead, the future promises even broader and more transformative use cases for edge computing, revolutionizing how we live and work. Despite its promise, edge computing faces hurdles. Cost is the biggest, with significant upfront investments in hardware and infrastructure. Security is another challenge. Each edge device is a potential entry point, requiring robust, multi-layered protection. Managing thousands of distributed devices adds operational complexity, demanding advanced automation and management tools. A shortage of skilled professionals further complicates deployment, as edge computing requires expertise across networking, security, and cloud. Organizations must invest in training and upskilling to bridge this gap. Addressing these challenges is essential to realizing the full benefits of edge computing. With the right strategy, the rewards far outweigh the obstacles. Edge computing is set for rapid growth, with more organizations moving from pilots to large-scale deployments. Investment will rise as real-time processing becomes critical for automation, AI, and smart infrastructure. Advanced use cases, like autonomous retail, predictive healthcare, and smart cities, will shift from concept to reality. Security will evolve, with zero-trust architectures and AI-driven monitoring becoming standard for edge environments. IT leaders should start with education, pilot projects, and upskilling teams in distributed systems and security. By building expertise and starting small, organizations can position themselves for success in an edge-driven future. The next era of digital innovation will be defined by those who master the edge,